Okay, right. In this lecture, we'll talk about another transformation based on greatest integer function, which is greatest integer of y equals fx. This is pretty simple. What we actually do, we draw, first of all, we draw y equals fx, and then the most important thing is, because this left hand side is an integer, so right hand side will only exist when this is an integer. Okay, that's it. Suppose my graph is greatest integer y equals x, then first we draw y equals x, and then left hand side is an integer, which means this x must be 0 or 1 or 2 or 3 or -1 and -2. Suppose greatest integer y equals 1.2, means if I put x equals 1.2, definitely it doesn't make any sense. So this graph will only exist at points where this right hand side means x is an integer. Okay, so suppose greatest integer y equals 0, which means y belongs 0 to 1. So at x equals 0, y coordinate varies between 0 to 1. At x equals 1, greatest integer y equals 1, which means y must be 1 to 2. Another candle at this particular bit. At x equals 2, greatest integer y must be 2, which means y must be 2 to 3. Okay, this. At x equals -1, greatest integer y equals -1, which means y must be -1 to 0, but not 0. This is the reason arrows. At this x, y equals 1, y equals 2, y equals 3, y equals -1. Likewise, at this particular x equals -2, y varies from -2 to -1. This is the graph. Second graph, greatest integer y equals x square. This is y equals x square. Now this right hand side, this side must be an integer, which means y, greatest integer y could be 1 or 2 or 3, which means x could be x equals 1. Graph will only exist at x equals 1, at x equals under root 2, at x equals, this is under 2, this is under root 3, this is x equals 2. Likewise, -1, minus root 2, minus root 3, -2, and x equals 0. Suppose x equals 0, which means x square 0. Left hand side is greatest integer of y equals 0, which means y must vary between 0 to 1. So at x equals 0, y coordinate varies from 0 to 1. At x equals 1, greatest integer y equals 1, which means y must vary between 1 to 2. So likewise at this particular place. At x equals under root 2, x square equals 2, greatest integer y equals 2, y must vary between 2 to 3. 2 to 3. Graph is symmetric about y axis. At x equals 2, this is 4, y, okay, under root 3, under root 2, then under root 3, 3 to 4, 3 to 4, and then at x equals 2, value varies between 4 to 5. Next graph, greatest integer y equals log x. First we draw y equals log x, this graph of log x, base e, and then left hand side is an integer, which means this value could be 0, y equals 0 at x equals 1, y equals 1 at e, y equals 2 at e square, y equals 3 at e cube, and then graph is going to be very compressed, so I'm not going to talk about between 0 to 1. However, I'll draw at one particular point. Suppose at x equals 1, this value is 0, which means greatest integer y equals 0, which means y varies 0 to 1. So 0 to 1. At x equals e, if you put x equals e log e to the base e is 1, which means greatest integer y equals 1, which means y varies between 1 to 2. So at x equals 2, y varies this. At x equals e square, greatest integer y equals 2, which means y varies between 2 to 3, and then this point 3 to 4. Okay, at this particular point, suppose minus 1, left hand side is minus 1, which means log of ex, which means x equals e raised power minus 1. This point is e raised power minus 1. At this point, greatest integer y equals minus 1, so value is this. And then so many points between 0 to 1, because it could be minus 2 at this point. And this is going to be compressed. It's very difficult for me to draw now. Okay, greatest integer y equals e raised power x. Again, y equals x. Graph of this value could be 0 or 1 or 2 or 3. This is y equals 0. We don't have any real x, we don't have any point on real axis which could provide y equals 0. So definitely graph will not exist on this side at any point. However, at x equals 0, this value is 1. Okay. Okay, right. We don't have any zeros. Okay, this cannot be 0. It can be 1, where whenever this is 1, e raised power x equals 1, which means x equals 0. When this y coordinate is 2, we have this x coordinate is log 2 to the base e, which means varies between 2 to 3, and then log 3 to the base e, y coordinate varies between 3 to 4, and this so on. Again, about this point, when x is less than 0, e raised power x is is less than 1 but greater than 0. Okay, which means greatest integer y, which means left hand side greatest integer y varies okay, and we don't have any integer which is greater than 0 and less than 1. Okay, right. What about this transformation, greatest integer of y equals greatest integer of f, and then input is greatest integer of x. Okay, so input is greatest integer of x, then transformation of fx, and then transformation of y. Okay, so first thing is we draw y equals fx, then from it we transform our graph to y equals f of greatest integer x. So transformation of x at the first place, then second transformation is transformation of this graph. Okay, so transformation of this, and then eventually transformation of y. Suppose this is my graph. We need to draw greatest integer of y equals greatest integer of x. So first thing is we draw y equals greatest integer of x. This is my graph. 0, this is 0, 1, 2 and 3. This coordinate is 1, this coordinate is 2, this coordinate is minus 1, this coordinate is minus 2. Okay, now transformation, now this particular graph, transformation of y. Okay, now we are talking about this. Suppose between this 0 to 1, when this x is 0 to 1, there are infinite points on x-axis, and this will lead to greatest integer of x is 0. So no matter what you do, if x lies between 0 to 1, this value is going to be 0, which means left hand side is going to be an integer, like greatest integer of y is 0, which means there are infinite points which will lead to this x is 0 to 1, this gives greatest integer of y equals 0, which means 0 to 1, right, this, which means corresponding to x 0 to 1, there are infinite y. So this is my situation. Whenever x is 0 to 1, y coordinate varies 0 to 1, provided this particular line is excluded, means there are arrows, infinite arrows. So this boundary is not included. Likewise, this boundary, this particular line is not included. This particular line is not included. Okay. However, area of this particular region is 1. Situation is there are infinite y coordinates. For infinite x coordinate between 0 to 1, this line is excluded. Okay, I suppose we have done sufficient graphs on greatest integer of fx, greatest integer of when input is greatest integer, then transformation of y. Everything is done except fractional part and least integer. Okay, right.